What's up, y'all? I'm back. Okay, last section of the unit aside from the labs that we need to cover. So I'll probably circle back for a labs video, or we'll figure it out with having to watch the videos on these, because these labs are a little difficult to do even in the lab, simply because it's manipulating plants and certain types of plants, and we have sometimes not as much access to certain plants at certain times of the year. And it's actually because of some of these limiting factors. That's what we're talking about today. All right, so what's a limiting factor? If you have reached your limit, right? When I look at y'all and I'm like, I have reached my limit. What do I mean? I mean, like, I'm done. I can't go any further. Okay, it's the same idea with photosynthesis. If you're an athlete, or maybe you're a runner, whatever it is that you do, I think of like kind of physical fitness. There is a moment where like you peak. Like, I can't run any harder. I can't lift any more weight. I mean, yes, you can improve up to a certain extent over time, but there does come the point, hopefully, all of you have like reached your highest potential. So that's what we call, in a plant, they can only go so far with photosynthesis. Photosynthesis can only occur up to a certain point because there are a few things that limit the rate of photosynthesis. These three things would be temperature, light intensity, and the carbon dioxide concentration. So when we look at those, we can look at graphs. So you're going to have to understand how to read the graphs with these. So let's talk about temperature first. So as you can see, we have the idea of temperature. It is controlled by enzymes. So yes, think back to Unit 5. Hope you paid lots of attention. The enzymes in plants are also controlled by temperature. And there's an optimum or an ideal temperature that all plants like and want to sustain life. And y'all should know that, especially if you've ever looked outside. When the weather starts changing and it starts getting really cold outside, what happens to our trees and what happens to a lot of plants? Everything either starts to go into that hibernation type zone where, trees lose all their leaves and they look really ugly and sad. And then a lot of our plants and any type of crop that's not in a greenhouse, it's going to die because it can't sustain life at super low temperatures. That's why spring and summer are awesome, because we see all the greenery, because plants can start to photosynthesize and ultimately sustain life. So as we increase the rate of the number of collisions between substrates and enzymes, those reactions increase. So plant life is great. It's going well. As we decrease the temperature, you can see enzymes begin to denature, and that rate is going to, we increase the temperature to rates that are too high. Okay, the enzymes begin to denature, and that rate of photosynthesis will stop occurring. But you can also see here at lower temperatures, we're not going to have as much photosynthesis. So there is an optimum temperature for different plants. Some plants grow better in the spring. So I have spring varieties in my garden that I grow at the beginning of the season. And then I have to come back. So if a spring variety, I can plant anywhere from February to March and be golden. But then I've got to come back around April, June and plant some things that really love to blossom and bloom and produce vegetables and fruit, around that August, September zone, because they really love hot weather. So as a gardener, this is my jam. I get this. But I know some of y'all are like, I don't really care about gardening. Some of y'all don't even like vegetables, which is crazy. They're so good. It's all in the way you prepare them. Just saying. Okay, light intensity, next limiting factor. So this one is more of a graph that we have to look at, and it's going to level off. This is kind of what I was talking about with if you've ever just reached your peak and you're done, okay? So at some point or another, the light intensity will become a limiting factor, because at lower light intensities, the rate is going to only increase up to a certain point, and then it levels off because that rate just becomes constant. It can only photosynthesize, that plant can only photosynthesize to the extent where it can continue to produce glucose in the photosynthesis equation of carbon dioxide plus water in the presence of light and chlorophyll yields the glucose and oxygen, okay? And then the same concept is true of carbon dioxide. So y'all know carbon dioxide absorbed in the leaves to undergo or photosynthesis to occur. So again, at some point or another, this factor does become limiting because it can only absorb as much carbon dioxide as it physically can absorb in the leaves that it has. So we will have a leveling off, okay? And that factor will be limiting. All right, so that's limiting factors. I reached my limit with limiting factors. Go take that CFU, y'all. I'm so funny.